Okay, in this video, we're going to take our first look at a factoring pattern, and we're going to use that factoring pattern to do the difference of two squares. And so the pattern that we're looking at is that if I had a squared minus b squared, where a and b are just a term here, then that would factor into a minus b and a plus b. And it seems pretty convenient and whatnot, but let's go ahead and discover why that is. So I'm just going to do some work up in this area. You don't have to mark it down, but I'm just going to show you how. Actually, I'll do it off to the left here so it doesn't mess up your notes. So if I have a minus b times a plus b, okay, and I'm just going to zoom on over here, and if I were to go ahead and factor those out, or I should say multiply them out, do the claw, FOIL, whatever you prefer, that I would get something that looks like this. Okay. Now, what we notice is that in the center there, we have like terms that are opposite, positive AB, negative AB, so they're just going to cancel each other out. And we're going to go ahead and get, at the end of the day, a squared minus b squared. So that means is that this, this right here is equal to this. Okay, so we can use them interchangeably. So what that means is that if I can go ahead and get something in the form of a squared, a squared minus b squared, I can factor it using these. And I'm going to show you guys how to knock that down, okay? So step one is that we got to go ahead and get this as something squared times something squared. So the way that we're going to do that is that we can rewrite this as this guy right here, okay, minus, and I'm going to write 16 as 4 to the second power. So now I know that if I have this squared and I were to write a squared minus b squared, the bottom here is that a would actually be x and b would actually be 4. Okay, so now what we're going to do is that we're going to use the left-hand side of that pattern to drop these in. So I just write the left-hand side of the pattern, and I know that that's going to be a minus b times a plus b. So that means is that since I have these equivalent statements here, instead of writing an a, I write an x. So every a turns into an x, and every b turns into a 4. And so that's going to go ahead and give me, x minus 4 and x plus 4. And that's going to be my factoring pattern, okay? And like we've been doing, if we check each one of these, so I'm just going to check it over here. So I write this out, checking my work and see if I get the same thing. So x times x is x squared, x times 4 is 4x, negative 4 times x is a negative 4x, negative 4 times 4 is a negative 16. Those cancel out, and I end up with x squared minus 16, which is what I started off with, which we know is good. Okay, so that said, let's go ahead and take a look at setting some of these other ones up. All right, this next one we're going to look at, I'm just going to go ahead and line there, keep them separate. Okay, and what our mission is again to go ahead and write this as something squared minus something squared, so it fits this pattern so we can factor. So what I'm going to do is that I'm going to think to myself, okay, I have this business of 4x squared. So I can visualize that being, okay, 2x times 2x, right? 2 times 2 is 4, x times x is x squared, so I can write that as 2x squared minus 49, which I know 49 is a perfect square of 7. And now I go ahead and I have my a squared and b squared, and I'm going to say that a is 2x and b is 7. So when I write out the factoring pattern, which is a minus b times a plus b, make that look like a minus sign. Okay, I just drop in the values for a, which is going to be 2x, and b minus 7 and 2x plus 7. And that follows a pattern. So let's go ahead and give it a check, because I'm going to box that in, say that's our proposed solution. So we check this. So we go 2x minus 7 times 2x plus 7. And let's do our claw or our FOIL technique. We got 4x squared and a minus 14x. I'm sorry, positive 14x there. Then a minus 14x, and then a minus 49. These are going to go ahead and cancel each other out because they're opposites. And at the end of the day, we'd get 4x squared minus 49, which we know is the same as this there. So we know our factoring pattern is correct. Okay. So moving on to the next one. Now this next one right here looks a little bit like, whoa, I don't have any perfect squares. 3 is not a perfect square, and 75 is not a perfect square. But one thing that we can check for is that we can factor something out. So if it doesn't quite fit the perfect square prototype here, what we can do is factor something out. And we could say, all right, well, what is the number that's going to go ahead and be able to divide into 3 and 75 evenly? And that number is going to be 3, okay? So let's take a look at how that's going to work. So I'm going to say if you already know how to factor these out, okay? I'm just going to write this down below. We'd have 3x squared minus 75. So again, if you're someone that's good with factoring, you could say, okay, 3 can go into each one of those evenly. So you divide each one by 3. That 3 comes out in front. Those cancel out. So I just end up with x squared minus, and then 75 divided by 3 is a 25. And now I have something that could go ahead and be considered the perfect, the difference of two squares. Because this is a perfect square, and this is a perfect square now. So what I can do is that I bring down this and this, and I'm going to factor these out by doing the little factoring pattern, right? And so this is ax, right? And this is going to be minus this. And so we can write this then as x squared. Oops. 1 second. I can go back here. Minus 5 squared, like that. Inside of there. And now we can match these up. And so I have, oops, my marker's not working. Give me a minute. Is that a is going to equal x, and b is going to equal 5. So we're just going to be plugging them into this pattern like we did before. Okay, so this would leave us the pattern then. We would go 3, and then we would have the pattern a minus b and a plus b, like that. And these would go ahead and just be dropped right in. So all the a's turn into x's and all the b's turn into 5s. So at the end of the day, we'd get 3x minus 5 and x plus 5. And that would be our proposed solution. And we'll see if we're correct by checking it. So to check, again, setting it on up, we think that it factors into this. We're not certain, but we're going to check it out. And again, we want to FOIL first. So bringing down the 3, we're going to get x squared plus 5x minus 5x minus 25. Oops. And this in the middle, we know are going to cancel out their opposites. And so we end up with 3x squared minus 25. And when we put this back in, we're going to go ahead and get 3x squared minus 75. And we know that that checks out. So we're good. And finally, we have one that has a negative sign in front. So when we have a negative sign in front, we always want to pull that thing out. It's way easier to do stuff with that. So here's our negative. And so we go negative, and the x squared was negative. Now it's a positive. This is a positive. Now it's a negative. Okay. And so I would have x squared minus 4. Okay. So what we want to do is that we want to rewrite this as the difference of squares. Okay. So I'm going to do it without all the pattern and stuff like that right here, and just kind of verbally go through this and see if we can follow. So we would have a negative, and in this case, we're going to write in there x squared minus 2 squared. Okay. That. And then we use the difference of squares. Since we got it all something squared, x squared minus something squared right here. So that's going to give me, bringing that down, x minus 2 and x plus 2. Okay, and that's my proposed solution. And like I said before, checking it out, see if it works. So I have a negative x minus 2x plus 2. And the first thing we want to do is FOIL. Here, so bringing all this down. X squared plus 2x minus 2x and minus 4. These cancel out. I have a negative and bringing this down. X squared minus 4. And then finally, distributing that negative in there, I get a negative x squared plus 4. And you can see that this right here is the same as this, so I know that I'm correct. Okay, checks out. So that's how we navigate the difference of squares. And it's a very valuable factoring pattern that we use quite often. And it's worth practicing and getting it down. So we're going to end the whole factoring packet, if you will, on this difference of the business of the perfect square trinomials, which is going to come up next, which is a factoring pattern of sort. Yeah, from there we'll take it and finish things on up. So that's how you do that. See you in the next video.